Hey, Algebra 2A people, we are finishing this SAT practice today. It's Wednesday. We left off on number 23, so now we're on number 24. It's a circle question. You should instantly realize it's going to be a geometry question. Anyways, circle above AB is a diameter. That's helpful. Okay. If the length of the arc ADB, that's this right here, is 8 pi, what is the length of the radius of a circle? All right, now here's something that's super helpful. You could go back to the very front where it's got all these formulas and realize that there's circle formulas right here. There's area and there's circumference. Now this gave you half of the circumference, so you hopefully should be able to realize that this is the other half of the circumference, so that the circumference, C, is these two combined, which would be 16 pi. Okay, then I'm going to come back to this formula for circumference. Circumference equals 2 pi r. Circumference equals 2 pi r. We just figured out the circumference is 16 pi. So 16 pi equals 2 pi r. Hopefully you can figure it out from here. But if I divide both sides by 2 pi, this will go away. The pi's cancel out. 16 divided by 2 is 8. And so I have my answer. R equals 8. Simple as that. Even though we haven't done that in my class, that's just looking at the formula sheet. All right, now we're looking at number 25. This one's a little bit more difficult. So it gives you these two functions, f of x and g of x, and it says which of the following is divisible by 2x plus 3. And then it gives you a bunch of these things. Like if I were to take these two, f of x and g of x, and add them together, would that be divisible? If I were to take f of x plus 3 times g of x, 2f of x plus 3 times g of x, 3f of x plus 2 times g of x, it looks really complicated right off the bat. To be honest, this is a little bit more of a difficult question. Okay, so now here's what I would say. I would instantly look at the constants. Okay, the constant of this is 3. Now, up here, there's only one constant, and that's 2. So if I were to take these two things and I were to add them together, it would have a constant of 2. Well, 2 is not a factor of 3. So right off the bat, I can say that A is not the right answer. Now, for the rest of these, I'm not sure. I could go through and try and figure out the constants, but that just helped me kick one away. Here's a different method too. If 2x plus 3 is a factor, and this is something you learned in my class, then that means one of the zeros would be negative 3 halves, which you would get by setting this equal to 0 and solving for x. Meaning if you plug in negative 3 halves or negative 1.5, then you should get 0. So now I'm just going to go down the line. I'm going to start with B, and I'm going to try it. I'm going to do my scratch work here on a separate sheet of paper. B says if I take f of x plus 3g of x. Okay. All right, so f of x is 2x cubed plus 6x squared plus 4x. Now I'm going to take 3g of x, meaning I'm going to take g of x and I'm going to multiply everything by 3. So x squared I'm going to multiply by 3. That's 3x squared. Now I'm going to add them just by stacking here. 3x times 3 is 9x, and then 2 times 3 is 6. Okay? Hopefully you can see that I stacked my x squared terms on top of each other and my x terms. So if I add these together, I get 2x cubed plus 9x squared plus 13x plus 6. If I were to check my constant terms, is 6 divisible by 3? You should say yes. Now here's what I mean by if I plug this in, I should get 0. If I come here and I take out every single x, and instead of all of the x's, and we've done this a lot in my class, I plug in negative 1.5. Now this I would expect you to do in your calculator. If I get 0, does this equal 0? If I get 0, then yes, this is one of the factors, or yes, it is divisible by 2x plus 3. If I don't get 0, it means it's not a factor. Punch this into your calculator, you realize, yes, you do in fact get 0, so the correct answer is B. Luckily, they put it near the top. If I were to take all the work to do C and D, you would punch them in and figure out it does not come out to 0. All right, now let's look at number 26. This is kind of a logic question. So it's giving you this. Negative y is less than x, which is less than y. And you have to figure out if this is going to be true, what of these three things needs to be true. Okay, so the reason that they say that is because if they don't give you any of these and then they just say this, I could easily give you examples that would make that false. For instance, if x equals 10 and then y equals 5. This is not true because 10 is not less than 5. Okay, boom. So instantly you know that x cannot be greater than 5. Okay. That right there is actually this. And I know it says absolute value of x has to be less than y, but that's just so you don't say something like, well, let's say x equals negative 10. Hey, negative 10 is less than 5. But negative 10 is not greater than negative 5, which is why the absolute value of x has to be less than y. All right, then we're going to look at these two things. X has to be greater than 0, or y has to be greater than 0. Now, 1 definitely has to be true. You can see every single answer has 1. Okay? Either 1 and 2, 1 and 3, 1, 2, and 3. So what I would do is I would go through and I would just try examples of what if x is negative and y is negative, or something like that. So for instance, if 1 and 2 were true, if x is greater than 0, so let's do an example where x is 10. But let's say I make y negative. So y is negative 5. Oh, that's not true, because 10 is not less than 5. So I know that this has to be false. Then I'd go say, well, what if y is greater than 0, but x could be a negative number? Okay. Okay, so for example, we're doing 1 and 3, so if y is greater than 0, let's make y 10. So negative y would be negative 10. So if this is the case, x can be whatever we want, except for we already said that the absolute value of x has to be less than y. So that means that x has to be in between 0 and 10. If I picked anything in between 0 and 10, like 5, that would make it true. So, hey, this is my answer. Done. All right, 27. Let's zoom out here a little bit. So we have a scatter plot, and it shows the relative housing costs. So like the guesstimate housing costs of the population density for several large U.S. cities in the year of 2005. Line of best fit. This is Algebra 1 stuff. It means it's going through those dots as accurately as possible, kind of through the middle of the data. Okay. So it has this equation. Which of the following best explains how the number 61 in the equation relates to the scatter plot? So we're looking here. Well, you do have to remember this is y equals mx plus b. So 61 is the y-intercept right here. So you're trying to figure out what does that mean in terms of the context of the problem. Well, that's where it's crossing the y-axis. Now, don't forget that the y-axis is the relative housing cost percentage of the national average. So that means that 61 guaranteed has to be a percentage. Choice A says that the lowest housing cost in the United States was about $61 per month. Not a percentage, so we instantly know that's wrong. Okay. Choice B, in 2005, the lowest housing cost in the United States was about 61% of the highest housing cost. I'm going to come back here. It says percentage of national average cost. If you read through C and D, it says percentage of national average cost. Okay, so that knocks out B. So now C says that in cities with low population densities, housing costs were never below 61% of the national average. Or D, even in cities with low population densities, housing costs were likely at least 61% of the national average. So they're really close. One's saying it's guaranteed never goes below 61%. The other one says that it is at least 60%. Sorry, it says likely at least 61%. So I'm going to go back to one word here, relative. Relative means about. So I cannot guarantee that the costs were never below 61%, meaning that my answer for this is D. Weird, because probably none of you have ever owned houses, but there it is. All right, we got 3 more. All right, 28. This one was a little tricky. Which of the following is an equivalent form of the function f above, in which the minimum value of f appears as a constant or coefficient? So the reason this is tricky is if you just take these two things and multiply them together, you will get x squared plus 2x minus 24. You'd probably circle that and you'd move on. But that is actually not the correct answer. The minimum value of f appears as a constant or coefficient. Anytime you see minimum value, you should realize that you are trying to figure out the vertex, okay? Because this is quadratic, which looks like this. We did a bunch of this, minimum values all the way at the bottom. There's a bunch of different ways of finding the vertex. I can tell you just based on looking at this that it's got 2 zeros at -6 and 4. So that means like if I were to graph this, the 2 zeros here would be at -6 and +4. Now, if you want to find the vertex, you could start by finding the axis of symmetry, which is halfway in between these two, which is at a -2, okay? Which you could find pretty quickly just by taking the average. -6 plus 4 divided by 2, which gives you -2. Now, -2 is the x value of the vertex. If I want to find the y value of the vertex, I got to plug it in. So instead of x plus 6 times x minus 4, I am going to plug in, that's a minus, -2. So -2. Whoop, just caught myself in a simple math mistake. This is -1. Whoopsies. Okay, because -6 plus 4 is -2, divided by 2 is -1. Whew, that would have sucked. Okay, so anyways, I'm going to plug in -1. That should make this work out a lot nicer. -1 plus 6 is 5. -1 minus 4 is -5. 5 times -5 is -25. So meaning the y value, or the minimum value, is -25. So you're looking for something on here that has -25. Boom, there it is. Okay? This is actually the same exact thing as f of x, but it's written in vertex form. But all you had to do here was find the minimum and then figure out which one of these said -25. All right. Number 29. Number 29 was a very tricky question as well. It's kind of long-winded, so people give up pretty quickly. And that's what they're looking to see. Are you going to persevere? So x is the average of m and 9. Y is the average of 2m and 15. Z is the average of 3m and 18. And you're trying to figure out the average of x, y, and z in terms of m. Okay, so let's write some stuff down. X is the average of m and 9. So if I took m plus 9 divided by 2, that's equal to x. That's the average. Now y is the average of 2m and 15. So if I were to take 2m plus 15 divided by 2, because that's how I'd find the average of those two things, I'd get y. Z is the average of, what does it say, 3m and 18. Boom. Okay. Now, if I wanted to find the average of x, y, and z, I would take these three things, I would add them all, and I would divide by 3. So here's the algebra that we need to do. Okay. Now, hopefully you can see that m plus 9, 2m plus 15, 3m plus 18, they all have the exact same denominator. So let's ignore this for a second. I can just put m plus 9 plus 2m plus 15 plus 3m plus 18 all over 2. And then I still have this giant 3 on the bottom. Okay. Now let's simplify things. Let's ignore these. I've got m, 2m, and 3m, so that's 6m. Then 9 plus 15 plus 18 is 42. Okay. Now I divide by 2, and then I divide by 3, which is the same thing as dividing by 6. Now I simplify. 6m divided by 6 is m. 42 divided by 6 is 7, and that is my answer. Now again, I can make that look pretty simple, but that's kind of complicated when you're looking at this problem. Where I come back here and realize that the answer is B. Had some tough problems here in the end. Here's the good news. Number 30 doesn't take nearly that long. Gives you a function. It even gives you the equation for that function. It's graphed here. And you have to say if k is a constant such that f of x equals k has 3 real solutions, which of the following could be the value of k? Basically saying if I were to take some horizontal line in here, can I find a horizontal line that touches this cubic 3 times? So let's see. A says k equals 2. That would be right here. Does that touch my cubic 3 times? No. B says k equals 0. That would be right here. Does that touch it 3 times? No. C says negative 2, meaning right here. Does that touch it 3 times? No. Our final answer, which you probably figured out already, is correct. D says negative 3, but just to show you, if I put a line at negative 3, see how it touches my cubic 1, 2, 3 different times. So it actually have 3 different solutions. All right, there it is. As the SAT practice, we're going to be doing a little bit more SAT practice next week. That is all done for this one. Feel free to take pictures of this, send it to me so I can give you extra credit. If you're trying to get your grade up, this is the best way to do it. Cool. All right, miss y'all.